The first part of this question is asking us to find the equivalent capacitance between points A and B for this group of capacitors, and then it tells us what all the different capacitances are. So the first thing we're going to do is figure out what's in parallel and what's in series. So these two, they are in parallel. And we know the equivalent capacitance for things in parallel, we just add them up together. So this is going to be equal to C2 plus C2, and we know that C2 is 10 microfarads, so this is 20 microfarads. These guys here, C1 and C2, we see that these two are both in series, and we know that their equivalent capacitance is going to be equal to 1 divided by C1 is 5. I'm going to stop saying microfarads because it's just kind of repetitive, plus 1 divided by C2 is 10 to the negative 1, and that's going to be equal to 3.33 microfarads. If I were to draw this out, I now have this situation where on the top I have 3 capacitors like this, and on the bottom I have my 1 capacitor. This one is 20, 3.33, 3.33, C3, and the next step is to say, okay, well, these guys are all in parallel. I can add them up together. The equivalent capacitance here is going to be 3.33 plus 3.33 plus C3 we see is 2. Add that up and I get 8.67. And then I have this situation where I have 1 capacitor like this, that's 8.67. And then I have 1 capacitor like this, that is 20. I can just add that here, so this is 20, 8.67. These guys are in series, so we can add them up as such. The final equivalent capacitance is going to be equal to 1 divided by 20 plus 1 divided by 8.67 to the negative 1 is equal to 6.05 microfarads. So that's our answer for A. Now B wants to know what charge is stored in C3. And this is actually kind of tricky because we have to reverse engineer a problem a little bit. What we do know is that, so this was the end results. What we do know with this part that we were at here is that, okay, well, these are in series, right? So we know that when we have things in series, they have the same Q. So that means this plate here, the 8.67 plate and the 20 plate, they have the same charge Q on them. And we know that this pink region was actually part of this bigger blue region, which was actually part of this really large region here, right? So the first thing we're going to do is figure out, well, how much charge was on the 8.67 and 20 plates. So what I say by that is that in the upper section, we're going to call that the 8.67. In the lower section is the 20 section. They have the same charge Q as the charge that was on the equivalent capacitor. In this one, if you remember, this was the 6.05 microfarad plate. And we know the equation for that. So Q equivalent is equal to C equivalent times delta V. And we know what delta V is from a question. It's 60 volts. So this is going to be 363 microcoulombs. So there's 363 microcoulombs on this plate here and on this plate here. We can forget about the 20 for now because we really care about C3 here. Now the next part is to say, well, okay, if there was 363 microcoulombs coming in here, well, they didn't all get that same amount of charge. They got a different amount of charge each. But what we do know about something that's in parallel like this is that they have the same potential difference. So each one of these, 3.33, C3, and this 3.33, have the same potential difference. So what we can say is, well, delta V upper, because we're just talking about the upper region here, is going to be equal to that charge we had divided by C equivalent. Because remember, these three are acting as though they're just one capacitor with an equivalent capacitance. So then, if we figure out what delta V is, we just plug in these numbers. So it's 363 microcoulombs divided by their equivalent capacitance. This is 41.9 volts. So what we're saying here is that this one has 41.9 volts across it, which is the same as all of these ones. So they all have that same potential difference across them. Now we need to figure out what was the charge on C3, and that's easy enough. If we know that was delta V upper, we know that Q3, the charge on capacitor 3, is equal to C3 delta V3, which is this, right, is equal to 2.0 microfarads times 41.9 volts. And that is equal to 83.7 microcoulombs. So that is how much charge ended up being on that specific capacitor.